Okay, here we are on the last page, page 5 of this, and you might need to do this one in your math notebooks because some of these take, like especially the quadratic formula ones, take a lot of space. Now what you're going to notice is that we're going to be solving the same exact equation. Notice it's the same, but we're solving it in 3 different methods so you can see how all the different methods will work in these. So let's go check it out. Solving by factoring, starting with the first one, we're going to look to see, hang on, what times what equals negative 15 and subtracts to give us negative 2. So hopefully you're thinking 3 and negative 5. So my factors are x plus 3, x minus 5. So I first got the factors of my trinomial. Now I need to set it equal to 0 in order to solve by the zero product property. If these multiply to give me 0, then one or both need to be 0. So I'm getting solutions of x equal to negative 3 and positive 5. Remember that if my factors are positive 3 and negative 5, then my solutions are the opposite, negative 3 and positive 5. Now when I just solved this quadratic, what did I just find? I found that my parabola is touching at negative 3 and 5 on the graph. Okay, so that's what, when I solve and get solutions of a quadratic, that's what I'm finding. Now let's go solve this same exact one by completing the square. If we've done it correctly, we should get the same answers. Step 1, make space. Sorry, when we're solving to complete the square, we are going to set it equal to 0 when we do this. So step 1, make space. Step 2 is the b work. So negative 2 divided by 2 is negative 1 squared. That's going to have me add 1. Okay, hang on. How did I show you guys to do this in class? I think I showed you to add the constant right away. So hang on, let me go a step back here. Okay, so unlike converting to vertex form, instead of keeping the f of x equals or the y equals, we are going to start out immediately setting this equal to 0 so we can solve. And how I showed you guys in class when we did this to solve by completing the square, we moved the constant over first to make space to complete the square. So now I'm going to go do the b work of negative 2 over 2, which is negative 1 squared, which is just adding 1. Whatever I add to one side, I add to the other. So unlike converting to vertex form, where we add and subtract to the constant, we're actually just going to add to both sides to balance. So on this left side, I'm left with 16. On the right side, I get the x minus 1 squared perfect. I'm now able to solve by taking the square root of both sides. The square root of anything squared is just going to leave me x minus 1 squared. And on this side, remember, there's a plus or minus 4. Add 1 to both sides. I'm going to get 1 plus or minus 4 is equal to my x. And I'm going to solve both of these. So the first one is going to be 1 plus 4. Right here, 1 plus 4. So x is going to be equal to 5. And then the second one is going to be 1 minus 4, which is equal to negative 3. And when I go look at my answers, I'm like, oh, hey, they're the same answers as I just got on part A because it is the same quadratic. I just solved it with a different method. And then finally, let's go solve it with quadratic formula. So I'm going to write the formula up here at the top. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Yep, remember me singing that in class, annoyingly. Okay, and so you guys have to get me A, B, and C to start. Actually, let's write it over here. We're really going to be squished for space. So does everybody see that my A is an invisible 1 right here? My B is a -2, and my C is a -15. So let's highlight this so you can remember that the 1 comes from right here. The -2 comes from what's in front of the x, the middle term. And the -15 comes from the end there, your constant. Okay, now we go plug into the formula. I always get the formula ready with empty parentheses. B squared minus 4 times A times C all over 2 times A. So here I go plugging in the -2, my B again. Plug in your A, plug in your C, all over 2A. So where did these come from in case you need to see? The C value is right here, the -15. The B value is right here, the -2. And the A value is right here, the 1. Plugging in A, B, and C. All right, so simplifying this down, I always think it's easiest to do the front and the bottom first. -2 becomes +2, 2 times 1. And then we'll do the discriminant, or the part under the square root. -2 squared is 4. Minus 4 times 15, negative times negative is positive, 60. So now I can split this up, 2 over 2, plus or minus. The square root of 64 over 2 is 1 plus or minus 8 over 2, or 1 plus or minus 4. That gives me my answers of 5 and -3, like I just had on the previous two. Okay, so solving with all three methods, I should get all the same answers also on this next one. And I'm actually going to skip and go down to, I want to not do the ones with a coefficient first. See this coefficient of 2? I'm going to go down and do the other ones next, and then I'll go back up to the middle. So here we're going to solve by factoring. What times what equals 21 and subtracts or adds to 10. So it's going to be x minus 3, x minus 7. Solve each piece using the zero product property. Now when I solve using the other methods, it should work out the same. Set it equal to 0 first to solve. So step 1, move the constant. Oops, forgot a little x right there. Bad teacher. Step 2, the b work. So -10 divided in half. It's going to be -5 squared. So I'm going to be adding 25 to complete the square to both sides. It's going to leave me a 4 on the left and the x minus 5 squared perfect on the right. This factors to x minus 5. I'm now ready to square root both sides. I'm left with plus or minus 2 is equal to x minus 5. Add 5 to both sides. I get 5 plus or minus 2. So you'll notice that 5 plus 2, my first answer is 7. 5 minus 2, my second answer is 3. Looking back at what I just got on the one before, do you see that I got 7 and 3 again? Okay, let's go solve using the quadratic formula. It should be the same thing if I've done it correctly. X equals -b plus or minus square root b squared minus 4ac all over 2a. So get me a, b, and c. This right here is a negative 10. And then go plug those in. So it's negative 10, negative 10 squared, 4 times a times c over 2a. So negative 10 is positive 10, positive 2, square root of 100. Okay, so negative 4 times 21 is 84. Let's see if that works out right. Is that 100 minus? So 4 times 21, 100 minus 84 is 16. So we're going to split this up now. 10 over 2 plus or minus square root of 16 over 2. And so that becomes 5 plus or minus 4 over 2, or 5 plus or minus 2. And so that gives me the 7 and the 3 again as my answers. So you'll notice again that you got all these same answers by doing all three methods. Okay, with a coefficient in front, it means we're going to have a greatest common factor this time. So a 2 divides out, leaving me 10x plus 16 right there. And now I do the x on this. What times what makes 16? And adds up to 10. And that's my 2 and my 8. So 0 is equal x plus 2, x plus 8. By zero product property, we set each factor piece equal to 0 and solve. Now notice that the 2 in front does not have a variable, doesn't have an x, so we don't need to do anything with that. Now go ahead and pause the video, try completing the square on that next one, see how you do. Okay, did you remember that when there's that coefficient of 2 out front, we've got to divide it out first? So take out the 2, and that leaves me x squared plus 10x. Oh, and then we should have subtracted the 32 from both sides for this constant to be on the left. Okay, now take the 10, split it in half. That makes 5 squared. So I'm going to be adding 25 to both sides to complete the square. So this is leaving me a negative 7. Oh, wait. Adding 25 2 times, which is 50. So 50 minus 32 is 18. And this over here makes the x plus 5 squared perfect. We now divide out a 2, leaving us 9 is equal to the x plus 5 squared perfect. We're now ready to square root both sides. Remember, that's going to leave me plus or minus 3 on the left, x plus 5 on the right, negative 5 to both sides. We get x is equal to negative 5 plus or minus 3. So negative 5 plus 3, that's negative 2. Negative 5 minus 3, that's negative 8. I get the same two answers I just got a second ago. Okay, last but not least, the full formula. You get A, B, and C, and we go plug in. Negative B plus or minus square root of B squared minus 4 times A times C all over 2A. So that's going to be 400 minus 8 times 32. That's going to be a big number. 8 times 32. 400 minus 256 all over 4. Start to split it up. Negative 20 over 4 plus or minus 400 minus 256 is 144. And that's going to end up as negative 5 plus or minus. Do you see how it's going to be 12 over 4? 12 over 4 is just 3. Negative 5 plus 3 is negative 2. And negative 5 minus 3 is negative 8. There's our same two answers that we got on the other two. How'd you do? Now remember that middle row is not something that we're going to need to be able to do on this.